Unit 1, Model of the Atom, Balancing Equations. The first step to balancing an equation is to find out how many of each element there are on either side of the reaction arrow. To do this, I write a list. All of the elements on the left-hand side of the arrow, all of the elements on the right-hand side of the arrow. It's always useful to make sure that you write them in the same order on both sides. Once you've got your list, you can then count up the number of atoms of each element. Here, we've only got one magnesium. However, we've got 2 oxygen atoms. On the product side, there are no numbers at all, which tells us we've got 1 magnesium and 1 oxygen. The next step is to look to see which elements we haven't got the same number of atoms for, and in this case it's the oxygen. We've got 2 in the reactants and only 1 in the product. We're obviously going to have to add something to the product side of the equation, but in order to do that we need to understand what putting a number in front of the product actually means. If we look at what it would mean if we wrote 3NH3, effectively that is exactly the same as writing NH3 plus NH3 plus NH3. That would give us a total of 3 nitrogens and 9 hydrogens. So putting a big number in front multiplies everything within that compound. So we start by asking ourselves, what do we need to multiply 1 by to get 2? And the answer is 2. At this stage though, we've now got to recount. We've got to recount all of the atoms that are present in the compound that we have just altered. Therefore, we need to recount the magnesiums. We've now got 2. And we need to recount the oxygens. We've now got 2. So whilst this solved our problem with the oxygen atoms because they now balance, we've got a problem with the magnesium atoms. So again, we do the same question. What do we need to multiply 1 by to get 2? So we'll put a 2 in front of the magnesium, which means we've now got a balanced equation. We'll look at another more complicated example using a chemical that you're not likely to come across in the exam. It's definitely not one that the exam board are going to expect you to learn, but they could give you it in a question and then ask you to use it. So that chemical is phosphoric acid, H3PO4. We're going to start off balancing the equation in exactly the same way. I'm going to count up the number of each type of atom on each side of the equation. What you've got to remember is that it doesn't matter if the atom appears in 2 different formulas, you add the total up. So oxygens appearing here and here, you would only include oxygen in your list once. So therefore, we've got 3 hydrogens here plus 1 gives us 4. We've got 1 phosphorus. We've got 4 oxygens there and 1 there, gives us 5. And we've got 1 sodium. On this side of the equation, we've got 2, 1, 5 and 3. At the moment, the phosphorus and the oxygen are balanced, so it's entirely up to us whether we decide to balance the hydrogens first or the sodiums. As a general rule, it's usually easier to balance an equation if you leave hydrogens and oxygens to last. So therefore I'm going to start by looking at the sodiums. So the question is, what do we multiply 1 by to get 3? I'm going to put a 3 in front of the chemical that contains sodium. Because the 3 affects the sodium and the oxygen and the hydrogen, we need to do a recount. Therefore, we've got 3 hydrogens plus 3 hydrogens makes 6. We haven't altered the phosphorus, we've still got 1, but we've got 4 oxygens plus 3 oxygens makes 7. And finally, we've got 3 sodiums. If we compare the list of numbers now, you can see that phosphorus works and sodium works, but hydrogen and oxygen are different. If you look at the chemicals that we've got on the right-hand side of the equation, by putting a big number in front of the water molecule, we can change both hydrogen and oxygen. If you're left with just hydrogen and oxygen to balance, it's always best to leave oxygen until last. So the question becomes, if we've got 6 on the left, what do we multiply 2 by to get 6? 3 lots of H2 makes 6. We haven't altered the phosphorus. We have altered the oxygen. We've got 4 here and we've got 3 here, which gives a total of 7. And we haven't altered the sodium. If you compare the lists now, you can see that they're the same on both sides of the equation, therefore the equation is balanced. Here's another example of a typical equation that you might actually be asked to balance in the exam, but it's got the added complication that one of the compounds has got a bracket in it. As long as you always count the brackets carefully, balancing this sort of equation is no harder than balancing the simple equation like the magnesium oxide one that we saw earlier. First, we'll count the atoms. The calciums are easy to count because they're not in brackets. When it comes to counting oxygens, the problem that we've got here is that we've got oxygens in brackets. So at this point, you need to remember what a bracket actually means. The formula for calcium hydroxide with the OH in brackets effectively means that we've got the contents of the brackets twice because of the number 2 outside of the bracket. If we add these up, you can see that we've got 2 oxygens here, and we've got another 4 here, which makes 6. Similarly, with the hydrogens, we've got 2 hydrogens here, plus another 2, makes 4, and then we've just got the 1 sulfur. The remaining addition, which is for the product side of the equation, is simple because we've got no brackets. As we said with the previous equation, if you're left with a couple of elements to balance and one of them is oxygen, it's always a good idea to leave oxygen to last. Also, if you're looking at 2 elements to balance and one of them only appears in one of the chemicals, that's always a good place to start. So in this case, I'm going to start by balancing the hydrogens. So it's back to the same question. What do we multiply 2 by to get 4? At this point, I need to do a recount of the hydrogens and oxygens. 2 times 2 makes 4. 4 oxygens here and 2 oxygens here makes 6, and the equation is balanced. The key to balancing equations is to always make sure that when you are counting your atoms up on each side of the equation, that you count them very, very carefully.